when we're doing product or process validation or verification in product development, a lot of talk about process or product capability. And so I've drawn basically a sketch of what that looks like conceptually. If we look at this line to be whatever, this is our customer requirement or customer need. And then this line here is the lower spec limit. We kind of just draw that boundary. And this is our upper specification limit on this side. If this is where our data falls from whatever testing that we created, this would be what basically a process capability chart would look like. And usually this data is shown in a histogram, and if it's not normally distributed, you can see that within that data set. This one's kind of a nice one because we've centered it. If this distribution of data goes one side or the other, there's risk of it falling out, or maybe it already did fall out, and the solution is to center it to be more capable, to have the full distribution within the spec window that we've assigned for our customer. So we've shown it nicely centered, which is desirable. Also, it could be perfectly centered, but then we look at basically how much distance do we have from the end of our distribution, roughly, to the edge of that spec limit. And I like to call that the guard band. If you have some guard band on both sides, then if it floats a little bit this way or that way, it doesn't really matter. Centered is ideal, but we know it'll never perfectly be there. So we have a lot of variations in our inputs. So we want to make sure to have some guard band to make sure that we can always meet the customer expectations down here. However, one of the things that's kind of gets lost in this process now, and there's a lot of math behind it. There's CP, CPK, PP, PPK. It's just as letters and labels for things. It kind of doesn't matter which math you're using to a point. What really matters is, how was this data created? Was this one lot of raw material with your best operator and your best machine, or a best technician back in the lab? Or was this really representative of a lot of variety, multiple vendor materials, and so on? And so the standard deviation, or the Greek letter symbol, sigma, the noise or spread of that distribution has a lot to do with how the data was generated. So you can do something that says it's really a long-term distribution, but done things in data collection or data generation that actually make it really a short-term and an ideal distribution spread. So think about how your data is collected, how it's generated. Those assumptions are key to knowing how much guard band do you truly have. And is this really centered, or is this biased unintentionally in a way that isn't representative of long-term? Because we do these type of capability analyses to predict what's the long-term performance going to be. Are we going to have points that are falling out of the spec limits, or should they all be contained? And that's all dependent upon how centered it is and how much guard band there is. But that also depends upon what's the spread of our data and the intentional spread that we created by using a new user, a new operator in the process versus an experienced one, versus maybe if you have two different vendors that can supply parts, you use both vendors instead of one lot from one material on day one. If you need some help with process capability, understanding it, using it, or solving issues you have with process capability, call us here at Prairie Solutions. We want to help make your process as capable as possible, as robust as possible.